Hey all, I'll start with a problem that is most commonly asked in many interviews. The problem statement, I'll just define directly the problem statement. It is you have to find the next greater element in an array. So let's say you are given an input array, and let's say the array looks like 6, then it could be 1, and then let's say it is 7. Okay, so the output looks like for 4 the next greater element is 6, for 2 the next greater element is 6, for 6 it is 7, for 1 also it is 7, and for 7 we don't have anything, so it is -1. Now whenever you are given a problem, the first thing that comes to mind is the brute force. So how does a brute force look like for this problem? It would be like we just simply iterate the array, and for each element we would iterate the remaining elements to find the next greater element, and the moment we encounter it we just break the loop. Okay, and since we are iterating the array in two for loops, it would be the complexity would be like big O of n square. Let's see how this would look like first. First, let's see how the algorithm or that would be look like. So whenever you are solving any coding question in an interview, always start with a function. Don't directly just start with a line for int I equals to 0. Always define the signature method signature, what this will return. Let's say since we want to return the uh, output array, the return type is an array for this. And for most of the coding questions, language is never a barrier, so always use the language of your preferred choice. Now here, let's see, we'll first, okay, I'll not define this one, I'll tell that. For int I equals to 0, I less than n, I plus plus. And this is how we write any algorithm for int I. The thing that you need to think here is that you have mentioned n but not declared it. So let's first declare what n is. N is nothing but the size of the array. Okay, fine. Now what we will be doing is for int j equals to I plus 1. So normally when we're writing two for loops, the hand directly writes like int I equals to 0, and the other loop as for int j equals to 0. But always be mindful of the thought that at what point you want to start j. So in this we want to start always from the I plus 1. Okay, and j less than n, j plus plus. Now what you need to do is if array of j is greater than array of I, you just need to fulfill the output of I equals to array of j, and you break this loop. Okay, now there could be a condition that uh, there does not exist any greater element for any particular element. Let's say in this example for 7, for rightmost element it will never exist. Okay, and let's say if the input is in the descending order, you will never find the next greater element. So what will happen? For 5 you will iterate it, you will iterate all 4 to 1, but you will not find, so you will next move on to the first I index equals to 1, that is the element equal to 4. So we'll have a boolean here. um, Boolean is found, and we will mark this boolean as true. Okay, and this needs to be in the first for loop. After this for loop we will check if this boolean is true or not. If it is not true, Then what we will do is we will output the value as -1. Okay, if the value is not found, we will simply output it to be as -1. Okay, and in the end we will just return the output array. Okay, have we defined output? No, and we are using it everywhere. So these things needs to be taken care of very thoughtfully. We will define it as int input equals to new int of size n. Okay, always think that you need to uh, do a dry run of your code, and just not on the input that is provided by the interviewer. Just try for several other inputs. Think of the worst case, think of the best case. The best case for this, even for the brute force, the best case could be big O n if the array is sorted. The worst case would be when the array is not sorted, or basically it is in the descending order. You should always ask these questions whenever, so you can ask whether the array is sorted or not. Let's say the interviewer says that the array is sorted, half of the game is already done, because even brute force will work. You can further question in that case that the brute force will work. Do you want to further optimize it or not? Okay. Another question that you should ask interviewer is that what is the range of the input, and are the integers all positive, where there is a chance of duplicacy or not. Before even starting the question, all such questions should be answered. Okay, now let's move on to the optimal solution. For this particular question, whenever we read, right, the next greater element or the greater, this word comes to our mind, and the first thing that strikes is sorting or binary search tree or heaps or something like that. But you should be very careful that it is just the next greater element and it is not the overall greater element in that array. The sorting will never work. So sorting doesn't work. You need not think in the direction of binary search tree as well. Okay, so think of, firstly think of the correct data structure and then go on to implement the algorithm. So let's further think what could be the best data structure here. We understood that sorting wouldn't work, so bst, heaps, all these are out of line. How about stacks? why the why stacks came into my mind? Because I always need to keep a hold of the next greater element. So let's say for 4 also it is 6, and for 2 also it is 6. And once I have encountered 6, I don't need to keep a track of 4 and 2, because till now I have found the greater element as 6. Now this will be useful going further down the array. So let's see how we can solve it using stack. We will go into the algorithm or the coding later on. First, explain the solution to the interviewer. So how you are going to do it with the stack? So we have a stack. We will push the first element in the stack. Okay. Now, what we will be doing is we'll be starting from the next element, and that would be your current element. So current element here would be equals to 2. So we will check, is 2 greater than 4? No. Okay. We will push 2 also on this stack. We don't perform anything. Next, we move on to 6. Okay. Is 6 greater than 2? Yes, it is. It means that 6 is the next greater element for 2. Okay, fine. Now you have removed 2. How about 4? You need to check for 4 as well. You need to check for all the elements in the stack which are smaller than the current element 6. So for 4 is also less than 6. So we will, for 4 also the value is 6. Now let we will push 6 onto the stack. Now when we have 6 in the stack and the current element is 1. Okay. Is 1 greater than 6? No. Just push it. Next is 7. Is 7 greater than 1? Yes. So pop 1 and the value would be 7. How about 6? Yes, 6 is also less than 7. So here it would be 7. Now let's say if it would have been 8 here. Okay, let me modify it a little and see how this algorithm works. So it could be 4, 2, 8, 1 and 7. Okay, so what will you do? So for 4 and 2, the value would straightforward come out to be 8. Then you will have 8 in the stack. Then you will have 1 in the stack. Okay, and now you are at 7. Okay, so you see 7 is greater than 1. Perfect. So you pop 7, and the next greater element for 1 is 7. Okay, now we see 8. Is 8 greater than, sorry, 7 is greater than 8? No. So we will not remove 8 and we will in fact push 7. Okay, now 7 is also pushed. The entire array is done. Okay, now we still have two elements in the stack. Whatever elements we have in this stack, the next greater element, there's no next greater element, and hence we'll output it as -1. Okay, so now let's see the how the algorithm will work. Okay, so again we will start with few of the basic things like this. Then we will have the output array of size n. Okay, so now you can say the interviewer that I'll assume that stack data structure is available because we are not modifying anything in the stack. Okay, so let's say now for int I equals to 1, I less than n, I plus plus plus. And before you did that, the first thing that we did was we pushed the first element onto the stack. Okay, the first element was a of 0. Also, you should always have the boundary conditions. What if the array is null? What if the size of the array is 0? We should always have those conditions here. Okay, let's say if a equals to null, then just what do you want to return? Ask whether we want to return null or you want to return an empty array. Okay, let's return it as null only. Okay, if the size of the array is 1, then just return -1. Okay, just one array, I mean just one element in the array with value equals to -1. Let's see will our algorithm will be able to handle it or not. If not, then we will add that boundary condition. Otherwise, we could just skip it. Okay, so for now, we have um, pushed the first element onto the stack. Okay, now let's say the current element would be what, stack dot top. Hmm? And we will see while stack is not empty. Always remember to add these boundary conditions, don't forget ever. And the value of current is greater than stack dot top. Sorry, the current here is not stack dot top, it is array of I. Okay, you can avoid declaring this variable. You can directly use a of I. It's just a method of coding, how you want to code it. So while stack is not empty and the current value is greater than the stack dot top, then what you want to do is you want to output the output of that would be what, stack dot pop. And okay, that's a stack dot pop. And we also want to push the current element. Okay. Now one thing you can ask me is, I have not mentioned the index of the output array. So what would be the index of the output array? We don't know that. How we will think, how we will get to know the output? Will it always be like 0, 1, 2, 3? No, it couldn't be, right? Because in the second example, uh, -1 was returned for 8, and while processing we will never get to know that, so we will need to push that as well into the stack. So how we can do is, so instead of pushing just an integer value, we can push a pair. So what the pair would look like is the value and the index. Okay, so it would be like, in that case you will have to mention that the stack will not just hold integer values but a pair. Okay, so I'll create a pair here, pair of integer comma integer. You can, rather than using a pair, you can use another data structure or just a class that defines this. It's up to you how you want to code it. Okay, so pair, I would mention it as the input pair equals to new pair. Let's say the values would be, for first it would be a of 0 comma 0. Okay, and this is what we are inputting here. Okay, now here the stack dot top will also not work because you want to get the um, pair. So it would be stack dot top dot get first. How do we write it? Is it dot get 0, or I think it's dot get first? I'll confirm it. So it's dot get first, and so it would be stack dot pop dot get first, and this would be output of. So let's do it like this. So pair of output equals to stack dot pop. Okay, and then output of out dot get second. Okay, and this would be out dot get first. Fine, and then we push stack dot push. Again, it wouldn't be not current, rather uh, you will need to push the index as well here, and this would be like what, current, and the index is I. Okay, so I intentionally first wrote current and then moved on to pair because I want to make you realize that you need the index for the output array as well, and that is important here. Okay, so we just did that. Now once we are done with this for loop, there could be some elements in the stack, so we just want to pop those elements and print the value as -1. So we'll have another loop as while stack is not empty, just pop those values and their output would be -1. Okay, okay, and this wouldn't be out dot get first, this has to be current value. Okay, output of out dot get second equals to current. Perfect. Now the complexity for this would be just big O n. We are just having one for loop, and if you say that we are having a nested while loop as well, but this is just stack dot pop or stack dot top. These are big O one operations that would not increase the order of the complexity. It would just add some complexity but not increase the order. So the order would still be big O of n, and in the end we just return the output array. It's always a best practice to explain the solution with some dry run. First explain the algorithm and then do it with a dry run. Okay, thank you.